All right, thanks everybody for joining. My name is Kelly Smith. I'm one of the product managers in the Backup and Recovery Solutions team at Oracle. Today I have Alex with me as well. He's going to be helping me answer Q&A. So if you have questions along the way, please put them in the Q&A. We'll be happy to answer. But let's get started. So I'm going to cover two things today. I'm going to cover a customer use case, talk about what they were doing prior to the recovery service. And here, I'll turn my camera on for just a minute. I don't want to kill everybody's bandwidth, but just to get us started. So I'm going to talk about a customer use case, what they were doing prior to using the recovery service, and then how things changed when they transitioned over to the recovery service. Because it's a more automated, secure, Oracle managed solution. And that really comes out in a lot of the functionality that's available. So we'll go through that. And then I'll talk a little bit about recovery service in the gov regions, because recovery service up to this point has been available in all the commercial regions. And we've gotten clearance now to allow the recovery service to be available in the OCI government regions. I'll talk about those, which ones they are, and then answer any questions along the way. So if you have questions, please use the Q&A. All right, I'll turn my camera off. All right, so I'm going to give you a quick overview of the recovery service, like how it's put together to give you a little bit of context before I move forward in the customer scenario. So we're talking about a highly secure, scalable solution for ransomware protection, essentially. And that works in databases that are, we've got databases in OCI, database services, and you see those top three. We've got database at Azure, and then database at Google Cloud. All those services are supported for recovery service. So all those backup services have done integration with the recovery service for automated backups. You probably saw the announcement a couple months ago, and the one that's missing here is AWS, and that's because the AWS database at AWS implementation will GA in the next couple of months. So you'll see that pop up on the list. We're already working with those teams to make that happen. So from a recovery perspective, we've got zero data loss protection with fast recovery. And the way that works, of course, is we're doing real-time protection of the database. As transactions are occurring, we're immediately protecting those transactions, sending them to the recovery service for recovery. And we're also using this incremental forever paradigm. So incrementals are being performed against the database, but we can synthesize a full based on those incrementals. So the recovery process is very, very fast, versus having to recover a full, then recover incrementals that follow that. When the incremental lands, a full representation of the database backup is created, so that when you do the restore, every single incremental from an RMAN perspective, it looks like a full. We do enforce data encryption. It's automated. We do compression during that process, and then we encrypt the data before it goes to the recovery service. That's an efficiency that saves space on your backup, so you don't get charged as much. And we're doing that in an automated fashion. During that encryption process, the keys that are used are owned by the database. So it's the database wallet that exists on the database itself. The keys are never stored with the backup. We don't, that's like leaving your keys in your car and parking it somewhere. We don't want to ever mix those two. So the keys live in a separate life cycle with the implementation that's been done for the Oracle database itself. And it's never owned or accessible from the recovery service. The database keys or the encryption keys stay with the database. We're doing continuous anomaly detection and validation across this whole process. So anytime data arrives, we're making sure that it's legible for us, like we know exactly what it is because we recognize Oracle data. We're doing, when the data arrives, we're actually breaking it all apart into blocks, and we're inspecting all the blocks We're making sure that every system change number that has occurred on the database is actually present and valid. So we're doing a lot of work to make sure that the data that arrives on the recovery service is actually valid data that represents the entire recovery window for your database. Next, we have backup immutability. We use and retention locking. So we have this concept in the recovery service so you can lock the retention of the backups. And what that means is no one can lower that retention lock. So even a sysdba, even the tenancy admin, any super user does not have the capability to turn that retention period down for those database backups because we don't want malicious users to follow that same path. So you don't have to worry about like a username or password getting compromised, and then all of a sudden they're wreaking havoc in your tenancy. We don't allow that retention to be lowered. You can increase the retention, you cannot lower the retention. We also have separation of duties and granular access control, so you can have policies separated. You can separate backup and recovery uh, operations. There's all kinds of, IAM controls that you can put around backup and recovery for the database services and who can control policies and set up backups. All this information then rolls up to the dashboard. So you get a really easy to understand roll up of the databases that are being protected, how they're being protected. We show the data loss exposure, which is essentially the last time that we've received data from the database. You can see the first database in the little table there has real-time protection enabled. It has a 0-second data loss exposure because we're constantly receiving data from that database as transactions are occurring. The other database down the list, the HR database, has a data loss exposure of 11 minutes, 7 seconds, because that was the last time that an archive redo log job ran, archive redo log backup job ran on that database. And then you see the recovery windows for that database. And the recovery window means that's the answer to the question of how far back in time can I go for my recovery. So you can see the first database a little over 7 days, second database a little over 15 days. And that's set as part of your policy configurations. You tell us how long you want to hold data for that database, and then the recovery service will purge it out after that. So that's controllable by you. And then finally, and you'll see this when we switch to the customer implementation, when we get down into the architecture, there's a logical air gap between the customer tenancy and where the recovery service infrastructure sits. So there's no access from the customer tenancy to the infrastructure that runs the recovery service. The only thing that connects the two is a private endpoint that only allows RMAN communication. So a very restricted private endpoint for communication. So RMAN backups can go, RMAN backups can be received, and that's it. All the operations for the recovery service infrastructure are run by Oracle. Load balancing, performance, patching, all that management happens in the Oracle managed tenancy by Oracle. So there's a logical air gap and a separation of duties there. So we're going to go into this large OCI customer case now. They're running Exadatabase service in multiple regions that needed, of course, to be backed up. They've got, $100+ billion revenue run, and they have over 100,000 employees. So they have hundreds of databases in OCI. They were leveraging backup to object storage for all these databases. But they had some challenges with that. The weekly full backups were becoming very, very painful because they're very time and resource intensive. When you've got that many databases on that amount of infrastructure running backups, they're having to worry about timing because all the databases that are on their infrastructure can't start database backups at the same time. There's all these problems around that because they don't want to impact database performance while these backups are running. And if you think about full backups, your database change rate is probably less than 5%. And a full backup is backing up everything. So that means 95% of the data you've already protected. So it's just a complete waste of time. And we want to get away from that. especially for large databases. Um, Also, with object storage, there was no way to introduce an operational standard. So you had DBAs setting up backups. They were picking their own settings for the backups. It was like the Wild West. They were doing what they wanted to do. So there was no way to standardize on an operational uh, in an operational way. And so backup retention was varied because it just was based on what the DBA who set up the backups picked that day. Retention could be changed. So if the DBA said, "Oh, I set it to 30," there was nothing stopping someone from turning that down. So when you're talking about a company that's trying to keep compliance across their fleet of databases, that becomes extremely problematic. And then backups weren't consistently cleaned up. Object storage is just a storage location. There's no logic around how to manage the lifecycle of the databases, um, which means that stuff can get just left around. Object storage doesn't know. It's just general storage. So backups were getting left around in their environment all over the place because it didn't have a life cycle wrapped around it. And then backup schedules are difficult to monitor. It was difficult to see what was happening in their environment when it was happening. Were database backups even running? Like they were constantly chasing after all of this stuff, and that's time consuming. Um, and of course, there was no way to monitor variance. There was no easy way to see, I've got all these databases, which ones are under which protection policy, which ones are being protected, what's did their jobs run last night? That was very hard to monitor all that information. And then, of course, with stuff getting left around, um, when you're viewing this from a billing perspective, it's very difficult to understand storage utilization and who's using that storage and object storage. Like, where did the data originate? And is the data important? Because you can't use simple rules like, is the data more than 30 days old? Because there may be a backup in there that needed to be retained for more than 30 days. So you can't apply simple rules when you're talking about all these different databases and different needs from different teams. And it was hard to connect the database backups to the databases themselves when you're just looking at general storage. And then finally, there was a separation of duty problem. They have all of these DBAs that are working in the databases. Some DBAs may not need access to do recoveries, for example. And it was hard to get a separation of duty between those DBAs to say, okay, this group of DBAs can do backup and restore. This group of DBAs can only do backup. That separation of duty was really, really difficult. Um, so now let's compare the two. So if we talk about weekly full backups being time consuming and resource intensive, weekly full backups are gone now. The recovery service does incremental forever, like I mentioned before. No more weekly full backups. Huge amount of time and resource savings. Um, the standardization problem in the recovery service, operations are all standardized. So if we look at this one by one, so backup retention varied. In the recovery service, retention is policy based. So you set a policy and then you just reuse the same policy over and over again. The retention could be changed. In the recovery service, retention can be locked. So the recovery service has this concept of locking the retention so you can't lower it. So they didn't have to worry about a malicious user turning down the retention of the backups. From a consistency perspective on cleanup, in the recovery service, all backups have a life cycle. They're tied to a retention, they're tied to some expiration date so that you don't have stuff that just sits around forever and no one knows where it came from or why it was supposed to be kept. At creation time, all backups have a life cycle. So we don't have to worry about stuff not getting cleaned up. And it's that life cycle is separate from the database. So when you're using general storage, the database is the one that's actually driving the cleanup and maintenance of that data. In the case of recovery service, the data lifecycle lives outside the database. So the database can be completely gone. Like it's a database you don't use anymore. It's been terminated. The database backups still have a lifecycle because they're controlled by the recovery service. The recovery service makes sure that database lives through its lifecycle and is cleaned up at the end. Backup schedules are difficult to monitor. All the scheduling is standardized in the recovery service, so it's really easy to figure that out. And you see when the database was last protected. We saw that data loss window, so you can keep tabs on that and put metrics around that to make sure that your databases are being protected on a regular basis. There was no easy way to monitor variance with object storage. In the recovery service, there's a dashboard. I showed you that like just for a brief moment in the overview we did at the beginning. So that dashboard, you can just look down the chart and it's easy to understand variance. It's easy to see a policy that's different from all the other databases. You can sort on the policy column and see the policies and understand if there's a variance in policy. You can see if there's a variance in the retention window. You can see if there's a variance in how often the database is being protected. And then, of course, this whole storage monitoring thing, right? When you've got generalized storage and all this backup is going there, how do you keep track of all that? In the recovery service, each database has storage reported with it. So when you're either in the database console, the database management console, or in the recovery service, you see specifically what the storage usage is for that database for backups. We also do a prediction forward with the recovery service so that you can see, like, if I just brought on a database and I've got a 30-day retention configuration in my policy, as soon as that database arrives, I can see what my 30-day storage utilization is going to look like. So I can plan ahead. It's not a surprise 30 days from now how much storage my backups are using. You were told that from the beginning. So it helps you do planning and have some important business conversations with those database users. Separation of duty. As I mentioned before, backup and recovery operations are available individually, and you can set policies around that. It's very easy to ensure that DBAs are in certain groups don't have access to certain operations. Not everybody needs recovery permissions, if you will, or that recovery workflow. You can separate that. Okay, so now let's move on to the architecture. So they have an MAA Gold architecture. They've got primary and standby databases. They're in two different OCI regions. So they've got database services running in region 1 and database services running in region 2, primary and standby on each side. The recovery service, as I mentioned, is in its own tenancy. This was a huge win for them because they've got this logical air gap now, right? It's completely outside the customer's tenancy. All that infrastructure is not managed by the customer. They don't have to worry about any of that. They don't have to worry about patching. They don't have to worry about capacity management. They don't have to worry about load balancing. All that's handled behind the scenes in this fleet of recovery services, which is essentially a fleet of engineered systems that we sell on premises called the recovery appliance. So we've just got this fleet of these things running in the OCI region that manage database backups. As I mentioned before, there's a private endpoint that connects the customer subnet, whatever subnet the customer chooses, which also gives the customer flexibility for communication control, right? They can specify a specific subnet to be used for backup. Private endpoints are put in place in that subnet, and that is the RMAN communication connection, right? That allows RMAN to send backups and retrieve backups. That's the only communication that goes across that line, is the catalog connection and the backup and restore operations, and that's specific for RMAN. And then restore can be done from any direction. They can restore from region 2 to region 1, inside region 1, inside region 2, back and forth, like however they need to, based on their needs for their environment. So overall, that was their architecture. They have 100% of their databases running to the recovery service at this point. Took us a few months to get there because they were doing it in a rolling fashion across these hundreds of databases that they have in these different regions. Um, but now they've got their monitoring set up. They're doing alerting, so they're watching thresholds. They can set an alarm based on how long it's been since the last backup, and that information gets returned to them if a backup got missed. Um, they're setting alarms on database backup health, so they know if anything's going wrong. Um, they also do for the recovery service, you request limits. They also monitor their limits utilization, so they know if they're getting close on their limits and they can request more limits to be added for their recovery service environment. Okay. Now let's look at the recovery service in OC2 regions. And I'm calling out OC2 specifically because we have if you look at the OCI information, right here, we have different cloud regions, but I'm talking specifically about the OC2 regions. We've got US Gov East in Ashburn and US Gov West in Phoenix, which I've highlighted here with these two boxes. This is the map for the United States and all of the regions that are currently available. You can see the legend over here. We've got commercial regions, we have government regions, and these are the two government regions that have been enabled. Um, there are some other gov regions that are upcoming. The government has to approve these regions, so there are some other government regions upcoming for the U.S. But these are the two that have been implemented at this point that we've gotten approval from the government for our service. So that means if you have infrastructure that's running in the government regions, if you have customers that have infrastructure, reach out to us, to me or Alex, and we can help you get capacity in those regions to make sure that those databases can be protected to the recovery service. We have a few customers that are already in line, and we're working with them already to start bringing those databases online. But these are actually active regions now that we can offer um, the recovery service as a solution to those database services running in those government regions. Okay, that's all the information I had to share today. It's a short session, about 30 minutes. I see one question in Q&A. Um, so the question is, how are long-term backups handled? Um, so long-term backups today have to be done through a manual process directly with RMAN. We do have an integration coming very soon that will all be integrated into the workflow. So you don't have to do anything outside of the standardized automated workflows. You can, from within the console, you can select that you want to do long-term retention for a particular backup, um, and the recovery service will handle that for you. So you tell us you want to do it, and again, you have to tell us how long you want to keep it. That's one of our requirements. All data has to enter the system with a life cycle. So you tell us how long you want to keep it, and then we will create the backup. This is the interesting part. So if you're familiar with creating long-term backups today, the database itself has to create that keep backup to store in object storage. Because the recovery service has all those backups already, we will create that keep backup for the database based on the backups we already have. So if you came to us right now and said, hey, I want to create a long-term retention backup based on November 15th at 8 a.m., and I want to keep it for 5 years. The recovery service won't touch the production database. We'll create that keep backup representation for you and hold it for that period of time. So we have the capabilities to use the existing backups to create long-term retention backups and keep that pressure off the database. We don't want the database to do that extra work. The recovery service will do it for you. All right, are there any other questions? now that we're here at the end of the session. Of course, the recording will be posted, so you'll be able to review that in the future, share it with anyone else. With
Until
that,
we get another one.
yeah, so pricing. Long-term retention backups will be billed differently. So we'll release all the pricing information that goes with that, but it will be billed differently. It's long-term retention backup, so it's in a different storage tier. So it will be billed differently. So when that functionality is released, we'll have all the billing that goes along with it. Okay. Any other questions? One thing I will encourage you to do is if you have any backup and recovery scenarios that you want us to cover in the office hours, please, please give us feedback on the backup and recovery um, AskTOM site. You can always request, a specific subject to be covered, and we'll be more than happy to do that. We'll put it on the schedule, and we'll let you know when that's going to happen. We're always looking for feedback about the information that you want to see, what's important to you. We'll continue to talk about new announcements, new upcoming things like long-term retention. We just had the government regions come on. We'll talk about AWS when that functionality arrives. But if you have any subjects that you would like us to talk about, you can definitely let us know. We had
Kelly, we have another one.
Yeah, one more question came in for backup and compression. Do we need to change anything in the database level? No. The backup compression is done as part of the RMAN process. So the database, you don't have to worry about the database. This is just all happening at the backup process, as part of the backup process. The other thing that I will mention around that, of course, is if you're using compression inside the database. Compression inside the database, of course, can't be compressed again. So if you've got, columnar compression, for example, turned on inside the database, and then you try to compress it again with the backup, you're not going to get any more compression because it's already compressed. You can't compress compressed. Um, so that's all handled. For on-prem, all statistics and reports can be extracted from OEM. So the recovery service is all obviously in the cloud, so not OEM related. It's all managed by Oracle, the OCI management framework. Um, and the statistics and reports can be extracted. They're all metrics. If you go to the Metrics Explorer, you can see all that. All that information is in the Metrics Explorer. You can get it in charts and tables and CSV files, however you want it. That's all in there. Because we're in the cloud, all that data is available, so you can see all those metrics. So it's similar to what you would do on premises with OEM, but this is all cloud related. Anything like RA format equals true. So RA format equals true is a setting that you put in your RMAN scripts when you're dealing with the recovery appliance on premises. The recovery service has been using that functionality since, oh goodness, for over a year. So the on-premises compression um, feature that just came out recently for the recovery appliance engineered system has been used in cloud since the beginning. And all those RMAN settings, all that stuff is handled automatically. You don't change any of that. You don't manage any of that. The automation does it for you. So that RA format equals true has been used in that automation for over a year. And it's something that's set uh, up specifically. So any special configure for no. So the automation handles all that. So when the database automation is looking at a database, it handles whatever needs to be done for that database configuration. Um, if it's a primary, if it's a standby, like it's a database, like, and the automation will do what is right to protect that database. Nothing that you have to manage by hand. The automation does all that for you. So again, one of the benefits of using the cloud, using the standardization in the automation that is wrapped around that cloud is Oracle handles all that for you. You don't have to try to do anything special. Actually, we don't want you to do anything special, because anything that you do that is quote special creates a variant, and then we have to worry about that variant. If you follow the automation, everything is the same as every other customer that's in the cloud. So we're talking about thousands of databases all being managed exactly the same. And we don't have to chase around all these little variants that you may introduce. So stay away from variants, stay within the cloud framework, and um, let the recovery service, let the cloud tooling, let it do its work. Analytics dashboard. We have a dashboard today. I don't know what you mean by analytics dashboard. I don't know the answer to that, because we have a dashboard, we have the metrics explorer. We're doing some additional integration with the monitoring team. So I don't know what the answer is to that.
Like Power BI or Oracle Analytics.
Power BI, Oracle Analytics. We don't have anything on our roadmap for that. I mean, Alex, do you know of anything?
Well, the only thing that I can mention, so we started working on the project to get a global health metrics view for the dashboard, so with the security team.
Right.
This is a pretty ambitious project, but we feel strongly that we really need it. So if you have like anything concrete in mind that you would like to discuss or request, please reach out to me directly. I would love to have this conversation.
All right, so let's answer that. Okay. Is it possible to do cross-region restores? You're saying ZDLRA. ZDLRA is the on-premises engineered system. So yes, it's possible there. It's also possible inside of OCI, inside the automation. You can create a database from backup. One of the first questions it'll ask you is which region do you want to put this thing in? And then it'll ask you all the specifics about the region. So yes, you can do cross-region. You can do cross-region as I mentioned before, in the customer use case, you saw that in the architecture, right? They're backing up their primary and their standby in two different regions. They can crisscross that. They can restore from region 1 to region 2, region 2 to region 1. All that's done through automation. So this is the question around. So then there's a question about speeds and size and statistics. So one thing you have to always take into consideration in the cloud, the bottleneck is going to be the resources that are available on the client. How fast can the client send data? How fast can the client ingest data from a restore perspective? It's all based on the client. If you think about it, we have base database service. I can have a one CPU base database implementation, or I could have a full rack of Exadata. The speed variations are wildly different between those two because they're just more capable systems when you get into a full rack of Exadata. So it all depends on how performant the client is. And there's performance characteristics for all those different client shapes. And you can also look at the MAA site. The MAA site did some performance observations for different shapes of the Exadata service. So look at what your client is capable of doing. The recovery service is always going to be faster than the client. So you have to look specifically at the client capabilities for IO. Because I can't restore data faster than the client can accept it, for example. So look at your client statistics. Lots of questions today. This is awesome. Everybody's got lots of questions on this Friday session.
Can you also mention about the channel allocation of the clients and just so the admin settings? So.
Oh yeah, that's a good. So again, based on the resources available on the client, if you look in the client, like the Exadata documentation, for example, has a chart in it that'll show you how many channels are allocated first based on the OCPUs that are available in the Exadata. So there's a chart that breaks it down. X number of OCPUs equals X number of RBAN channels. Because again, we're trying to balance the resources available on the client to the channels that are going to be available for backup and restore operations. So that plays a part in it as well. You're right, Alex. And that's all documented. If you look in the X data, they document all of that, how many channels are going to be opened. Any other questions this morning? This is good. All right. All right. So thank you for spending some time with us this morning. We're always grateful for your presence, your questions, lots of questions. That's always good for us. We really love that. And it kind of gives us some ideas on what to use for future sessions. So thank you so much for joining us today. We'll wrap up the session today. See us again here next month and have a wonderful weekend.